Thank you for joining us, and welcome to Large Geospatial Data Handling with Julia, in Julia. My colleague and I will be doing this presentation. From my part, I will do the introduction to the programming language and how the ecosystem for geospatial data is looking nowadays. Okay. If you have any questions along the way, please don't hesitate to ask. And this tutorial, at least for us, is meant to be really hands-on, so that you get really into the language and are able to run the examples and to actually code. So please don't hesitate to ask anything. And we will start from the beginning, from installing the language, running code line by line, and yeah, so it's really hands-on. So be prepared, okay? And thanks again for joining. So I will start with the agenda for today. We will have the short introduction, as I mentioned already, and the Julia Geo ecosystem. And that will be from my side. And for those that don't have Julia installed already, please go to this direction and start downloading the programming language. Here are some resources to start learning Julia. The first one is the official documentation, and the second one is an open source book that you can just download or browse interactively online. And the tool for coding that we normally use is Visual Studio Code. So also, come again? Yeah, sure, yeah. Where was I? Yes, so download the programming language. There are some resources for learning beside us here today. For coding, we use Visual Studio Code. But if you have notebooks, like normal Jupyter notebooks, that could also work. But yeah, we will need a little bit more of work in order to do it. The second part will be raster data loading and raster data analysis.
Is there any processing difference to use in the Visual Studio or in simple Jupyter notebook?
I mean, the workflow will be the same.
Yeah.
It will be exactly the same, but yeah, actually in Visual Studio Code, I would be doing a notebook as well. Okay. So it will be fine. Yes. As for the second part, I mentioned Felix will take care of raster data and the analysis of the data as well. And the last part, we will have some hands-on challenges, which might be some of your particular data, if you have something that you want to work on, or a challenge by Felix that he will explain later on. Or in my case, I will be doing data cubes visualization. So if you want to visualize data cubes with Julia, I will teach you how to do it, okay? So yeah, I will teach you how to do this kind of animations, which is a few lines of code. So.
I got a question. Can we download later this tutorial also? Or?
Yes.
Okay, so
yes.
it will be
so that
kept on
the presentation will be
this will all be recorded here, and we will also provide the materials that we are going to go to.
Yeah. So for the first part now of the presentation, I just want to give a general overview of the things that we are going to do. But later on, we will actually help everyone to code, okay? To download the packages to start coding. yeah, this presentation is just 10 slides. After that is coding. So don't, yeah. So the first part is what is and why Julia, right? So this was a programming language that was first published around 2012, and it was developed at MIT. It's a language that is compiled, so that means that you should always think about the speed when you do a second run, because when the second run is when your code is already precompiled, so it will be the fastest. You can declare types, like you will say this is an integer, this is a string, so you can do that if you want, or the compiler of the language per se will infer that for you. That's why it's optional. This can give you the best of C, the best of MATLAB, the best of Python. So that's the philosophy around Julia. One main difference is that it's function-oriented and not object-oriented as in other programming languages. So everything will be functions. And something that I really like is this thing about the two-language problem, where you prototype some of your code, and then at the end of the day, you want to optimize even further. So, and in order to do that, in other languages, you need to go into a different language in order to do it, like C or C++. In Julia, you just keep writing Julia. So you don't need to go to another language to do it. And the benefit of this for the ecosystem is that, at least in my view, is that every user that uses Julia is a new developer, so that all users can contribute to the whole package, to the whole programming language, okay? And the major thing for me, at least in my professional experience, is the project management. So in this case, this means that we keep the versions of the packages that we use fixed for that specific project, so that they don't get incompatibilities with other packages. So we isolate everything into project toms, we call them project toms. And we will teach that part here, how we do it, and what is the usual workflow that you should do when you are using Julia, okay? So this is a very important part, and we will dedicate a lot of time to do the project management correctly, or at least try to do it.
You mean that something like Conda is not necessary for Julia? Is it what you are saying?
Yeah, we don't use Conda at all.
So
It's completely independent.
Julia has an internal package manager, which is a standard library, which takes care of the stuff that Conda normally takes care of in the Python world. And you also have environments, which are similar to virtual environments in Python, but better handled, I think.
Yeah, but in different languages, for example, in C, C++, you have newer and newer libraries, standard library, version, and in Julia,
I mean, you could upgrade the versions,
and then the dependency is no more valid.
but in this case, it will only upgrade the ones that are compatible. So you will have hard bounds on which packages you are allowed to upgrade, okay? And that can happen. Yeah, more on that when we are actually working on it. Yes, so I think we have more slides. Yeah, who is using Julia nowadays? Of course, we are at the Max Planck Institute. Some people at Caltech, they have a big initiative to do air data modeling, and they have this framework called Klima. And for more case studies, you can go to juliahub.com, where they showcase like 100 use cases of companies and institutions that are using Julia around the world. Yeah, Of course, MIT is using it. I mean, the language was created there. And it's also used by the Dutch, sorry, the German weather stations. For us, at the Max Planck, we are using Julia because we want to bridge the gap between base model processes, where you have your equations, your previous knowledge, and you want to merge that with machine learning so that we do hybrid modeling. And that's our goal there, and that's why we are using Julia nowadays there. And yeah, for instance, this animation was done with Julia, with some of the visualization packages and some data loading. But yeah, this is part of our motivation to do it. As I was saying, we will talk about the package manager management later. Sorry. For now, this is just a quick overview of the things that you will do. So it's basically you go to one of your directories, you do activate the project so that it's isolated from all the global environments. You start adding packages, for instance, linear algebra. And you do that if you are a user, a normal user. You just go there and then you start using things. But if you want to develop or modify the package from someone else, you can do dev. And then you clone the repository from GitHub or GitLab or wherever is hosted, and you can download the source code and start modifying that package for your purposes, okay? And this project management environment, you can also, I mean, for the package, you have different modes. We have the package mode, that's how we call it, when you add packages or develop packages. You have the shell mode when you want to move to different directories, to create new folders, yeah, to move around your system, basically. And more importantly, we have help. So you can ask for help about almost anything, anything there. So for instance, pi, like what is pi? You can ask for that, and then you will get an answer. I hope we can do that later on once we see that you have Julia installed and start working on it. Yeah, packages. At the moment, there are more than 10,000 registered packages. So in general, finding the right package can be challenging. So that's why we are here, so to tell you where to start looking at, right? This is an old overview of some organizations from 2020. So each organization contains several packages. So yeah, it's just a general overview. As for the geo ecosystem, today we will be talking about large data sets. So we work with those data sets with JAX arrays, SAR, rasters, dimensional data, GeoMachy, Tyler, and GeoInterface, which Felix will be talking a little bit more later on. So at least in my day-to-day work, these are the packages that I use. Of course, there are a lot more, but I mean, you could start with this. Yeah. And for instance, the animation that is done here in the top right is done with Tyler and Machy, and the one below is done with rasters, GeoMachy, Machy, and dimensional data. So a combination of all these packages. So yeah, as in other programming languages, mixing packages is really out of the box. So it just works. Of course, you need to take care of compatibilities, but they usually are okay. And why it doesn't move forward? It's my last slide? No. My computer just it's not working anymore.
Okay, so while Lazo is trying to fix this, I just wanted to ask, who has Julia already installed on the computer? So, okay, so all of you, or does anybody need help to set up the system?
Okay, something broke. So yeah, the next slide was about to start coding. So that's basically it. But I wanted to give a general overview of all the topics that we are going to cover for the introduction. But just die. I don't know what happened. So please start with VS Code and we can take it from there. I'm restarting my computer. Yes.
Question. So, why do we use Python or TK or TCL in these systems? Basically, because there are a lot of libraries.
Yes.
And in my point of view, it's better to use. We are using for satellite images systems. It's better use Julia comparing to Python. Because it has more mathematics, mainly in radar images, and the question how can you import some MATLAB functions in Julia, because it's I think one of the most strongest mean to use Julia. So there are bridges. How can you import some MATLAB? So you are developing.
Yeah.
In radar, you are developing mathematical functions.
But in MATLAB,
Kalman filters.
we have packages for that, for Kalman filters in Julia.
Yeah. But if you have a huge package already done in MATLAB,
Yeah.
you don't want to recode all the things. And there are some cross compilers, or there are some tools can use.
Yeah, fair enough. I mean, I'm not aware of anything doing that rich for MATLAB specifically. The only package that I know is called mat.jl, but it's for reading MATLAB files.
Yeah,
Exactly.
So the important thing, because MATLAB, when I've chosen Julia, I've chosen because for MATLAB, you're gonna pay $5,000 or so.
Yeah.
Big bunch of money, and Julia can do most of the things, but not all. So and if we try to catch more, so there should be
Yeah, but again, I mean, because you just mentioned this, I mean, Julia is open source, so it relies on contributors that are willing to do that work for you, like to actually do the bridge between MATLAB and Julia.
I know, but if there are already, so you can Google it.
I mean, this is the one that I'm aware of, the one that I'm showing here, mat.jl. But other than that, I'm not aware of more work on this direction. For Python, as you mentioned before, for Python there is. So you can load almost any library from.
Cross-bridging, because we are using Julia also in
Yeah.
Python.
Yes.
That one already works. Yeah. You can do a bridge between Python and Julia, right? Fortran in Julia as well.
Yeah, Julia is Fortran.
Yeah. You can also encode.
there's also packages to call either Julia from R or the other way around.
Yeah, also for R, yes.
Yeah.
But for MATLAB, I never done MATLAB.
I think there are some, but I'm not sure.
There was a French comparison on the net. And they mentioned some bridges.
Okay. Yeah, I'm not using, I never used MATLAB, so I don't know.
Yeah.
A long time.
Somehow my computer is not showing. Sorry, it's always technical difficulties.
You should also show the use code extension.
Yeah, okay. So I just wanted to finish my last two slides. So besides all the ecosystem in Julia for doing geospatial data and handling the different data sources, we have a very powerful library for visualization, which is called Mackie. I don't know if this will work if I do play again. Yeah. So where you can do dashboards already, or you can do live exploration and animation as in the video in the middle, or you can do ray tracing, photorealistic renders for your images. So yeah, I just wanted to mention that we have this powerful library for doing visualization here. And yeah, this is the plan to work with Julia for those that are not familiar. So who is not familiar with Julia at all? Like, barely use it, right? So yeah, this is for those that haven't used Julia at all, and just to get you familiarized with the different components of Julia. So we will explore variables. What is a struct? Like, the struct is similar to classes in Python. How are the Booleans operators used? Functions. Multi-dispatch. Multi-dispatch means just to have the same function doing different things, depending on the input arguments. Keyword arguments as well for functions. Anonymous functions, conditionals. How to use strings, tuples, name tuples. I mean, that will become clear later. Arrays, and something that we use a lot in the Julia community is pairs. So when you pair things, like cat, 2, dog, 4. So yeah, you do a pair between things. And symbols. So this is the part of the session that goes into VS Code. I think the best is if I upload the notebook to the repo, and then everyone just downloads the repo and then follows along. I think instead of typing, or do you prefer to type? It's just like, like you mean
hands-on.
Yeah.
So
who is familiar with VS Code? Who has VS Code installed in their? So this is the part of hands-on. So this is basically my notebook. And for this, I mean, I would like everyone to follow along. And if you don't have it, please let me know, so that.
Yeah, whether we can get these.
So exactly. So I mean, the first part is: do you have VS Code installed already? This is a Jupyter notebook, but
people can also just follow along.
I have Jupyter also.
you also have a Jupyter notebook.
Yeah.
So, but you have the Julia kernel installed.
Yes, I have.
Yes. Okay.
Yeah, I have.
So who doesn't have Julia? I mean, the question here is who doesn't have Julia, so that we can help. Felix.
I think Julia's, you have still have a problem. Okay. I'll come to you. I just wanted to mention.
Send me the link to the repo, and add me as a collaborator so that I can push directly.
It's on Julia Data Cubes. We should be
No, I'm not.
You're not?
No.
Okay. Should be.
So we only have 2 people that are not there yet. So, okay, intro. So the first part is about project management. So I will start with that, and I will do a new file.
Show them how to install the VS Code extension.
Okay, project.
Yeah.
So for those that have VS Code and have Julia installed already on their system, you need to download also an extension for Julia in VS Code. So you go here to extensions and type Julia. And here you have Julia language support. Click, and then just click install. Okay? That one is supposed to connect the Julia programming language with VS Code so that you can use the kernel of Julia as the kernels that you use in Python. I mean, in my case, because I have it already, I will do uninstall, but I will not.
But how do you access this Jupyter notebook file?
The one that I prepare.
Yes.
Ah, okay. I need to, sorry, I haven't pushed this to the GitHub repo. I think I will share everything. Give me a second, sorry. Felix, I don't have permissions to push.
Why? I just made you maintainer. Should be.
And I don't have notifications. Ah, yeah. I can see it now.
You should be admin now.
I get 404. So in the meantime,
I'm just going to move it. And that you
the first part is project management. So even if you don't have VS Code of Jupyter Notebooks, you can always start Julia.
Oh, you should just.
What?
All right.
I don't have it.
You should get a notification now.
Okay, let me fix that.
Just a random question.
Yes. So for instance, if you, I mean, in my case, because I have Julia in my system already, I can do Julia.
Yeah.
I enter to Julia, and if I want help, I just use question mark,
Yeah.
and I go into help.
Okay.
And then, as I mentioned before, I can ask for pi, what is pi, and I will get the help for pi.
For that, you get the doc string for every function or type. And if you do help of the package, you would also get the README, either some doc string that the package maintainer wrote specifically for this module, or the README of the package,
Okay.
so that you could get everything directly from the rebel.
So yeah, that's basically how you ask for help. The first part is for functions defined.
Yes. Okay.
I mean pi or sign, and the last one is for a package. Okay, you can just ask for almost anything. And if there is not a match, you will get suggestions, like probably you meant something else.
So how can I download that from GitHub?
Yes, I'm just doing that. Sorry, because yeah, I'm just.
I need a password.
I don't know what is happening, Felix. I cannot. So the first part is project management. Okay. Just give me a minute to upload the whole thing. Good. So, okay, now it's up. So everyone should be able to. Yeah, I will show now then. Yeah, I'm trying to do that one bigger, probably in the repo. So that's the path, github.com, Julia, datacubes / So once you have access to that, you can go here and you can simply download the folder, okay?
From GitHub.
Yeah. And this is the path to GitHub here. This is the path. So that everyone gets the notebook. Please. Ready? Everyone has it? The name of the file? So there should be a new folder. And then inside the folder, I have intro BiDS'23 notebook. So everyone has the address, right?
Yes, okay.
And then what?
And so, with which file do we begin?
I will create a new file before moving forward because I want to explain a little bit more about package management. Okay. Yeah. After that, then we move forward. So, who is using VS Code? No one? One?
I use for C++,
No, but
now-
today, like 1, 2, 3, 4, and the rest is Jupyter Notebook, right? Okay. But we are all familiar with the terminal, right?
Yes.
So can we go all to a terminal session? And I think it's better to do it that way so that we are all in the same environment and how to deal with the project management of different environments.
Are we going to code in the terminal?
Yes. No code. We will not code. We will just see how the different projects are built, okay? But I mean, I will do the same in the notebook as well, but it's easier if we do it in the terminal.
I prefer terminal because I cannot install it.
You cannot install it?
Terminal is okay for install.
Terminal is okay. Okay. So for the next part, let's go, I will start with my terminal, okay? Oh. Is that big enough? Yeah? A little bit more, a little bit more. Something is off here, sorry, I need to change again the display. Yeah, I cannot see it. Yeah, I cannot change up to the bigger display now. Mirror. Okay, doesn't matter. Let's continue. So I will go to my folder, the one that you just downloaded. I know that that is in documents for me, and it's in BiDS'23 hands-on, right? And I know that there is a new folder here called intro. So we all should be here in intro. So in that folder, okay? Or any other folder, as long as it's empty, okay? I mean, for this part, it's not necessary to be exactly here, but any folder, empty folder will do. And then I will start Julia. Okay. So the default of Julia is that you will have a global environment. So when you are in the global environment, you will see the version of Julia that you are using, 1.9 in my case. Yeah. And if you want like the specific version, you can type version, like all in capitals, and you will get exactly which version you are using, 1.93. So if you remember from the presentation, we have these different package modes, right? So here in the REPL, you enter the package mode if you type bracket, right? So if you type that, you will get into the package mode. So I think I will do it like this so that we can see. Yeah. So now we are all in the package mode. But I want to make sure where I am now. So I want to see my current directory, and I am in intro. So that means that when I am in the package mode again, and I do activate space dot, I will be activating the environment within that folder called intro. Okay? So if I do that, enter, now you can see here on the left that it says intro. So that means that now your environment is isolated from the global Julia set of packages. And now, if I do st, which is the same as status, you will see that in your case it's empty, you don't have anything. You should not have anything. But in my case, I already have some packages because, I mean, I prepare something, right? And as I mentioned, you can do add random, for instance, which is a library that works with random numbers. So if you want to do permutations randomly, or you want to seed your experiments, this is the package that you should use, random. So you can do add random, and this will download a package called random, okay? To get out of the package mode, you do delete or backspace, depending on your keyword, and then you go back to Julia. And now that you are back to Julia, you can start using random. So you do using random, enter, and then you have the library random. And if you want to start with a different seed, random dot seed, and then you can provide a seed. So that's something that we usually do when we do experiments or run simulations, right? So this will fix my random seed to 1, 2, 3. And then you will be able to reproduce your experiment with that, right? So this is just one package. So, but there are more than 10,000 packages in the Julia register. Okay?
Work like Python, so if you load library, it stays in the memory, so can you reload?
What do you mean by stays on the memory?
Say you went to package manager, you updated the library, and then you save using random again. So does it load the new version?
Yeah, it will load the new version, yes.
So it's not like Python, because Python doesn't load it.
Doesn't load it?
No, from the current Julia session.
In the current Julia session, you will have the new version, right?
If you already loaded it before, no.
No, it's like Python.
If you would, I mean, it would.
I will throw you a warning that you are using a previous version, and then
If you already did using random, and now go back into the package manager. I mean, random is a bad example because random is a standard library, so
yeah,
it's always a fixed version with the Julia version, at least at the moment. But for any package, if you do some package and then you do using this package, and then update the package by the package manager, and then do using again, it wouldn't upload.
But
there is a package called revise, which would take care of updating the code you change, which is mainly for developing workflows.
When you
but
use revise, it works, right?
then it works most of the time. I mean, sometimes the changes are too big that you can't. And then sometimes you get a warning. If you do the update, you get a warning, this package has been used already, or so many packages has been used to use the new version, restart Julia.
Yeah. But you usually get a warning that you are using an old version. If that happens, then you just restart the kernel and yeah, it's quite fast, actually. I mean, there is not a lot of overhead. So yes, going back to the project management. So far we have done the package mode, which does the activation. You add a package, and the third option is to develop a package. So that means that you will copy the source code into your computer so that you can modify it if you need to. By default, you could do this. You could do dev, statistics, for instance. But then you will have this, this package in a global dev folder in the main path of Julia. So that's why here in my notes I put local, which means that I will copy this package only within this folder. And that's, I mean, that would be my recommendation, so that you don't mess it up with the rest of packages that you might be developing. So if you do this, local, so you will have a copy of statistics within intro, okay? So this is for development, but nevertheless it's important to know. And this means that you're cloning, so you are downloading the package. And now I will go out of the package mode, go back to Julia, and then you can enter the shell mode with semicolon here, okay? You go to the shell mode, and here I can do ls, for instance, or I don't know, what is in Windows is D, I don't remember. DLR, yeah. And you will see that now we have a new folder called dev, okay? And then you can even go further, so cd dev, so the usual, change directory, right? And then you are inside dev, and then you can see again that the package is actually there, statistics, okay? But this was just to show how to interact yeah, in the REPL and how different things work with the project management. Questions?
How get you from shell?
Backspace or delete, yeah. But be careful. If you type again, which is your current directory, you are not anymore in intro, right? So you should go back to where you were before if you want to continue your normal workflow, okay? So this is pretty convenient to move around.
So we have similar Python environment concept here.
In what?
Python environment can also define here, right?
No, I mean, a Python environment is completely unrelated to a Julia environment. So they will not even mix, okay? But if you want to install a version of Python within Julia, then you will need to have like a global Python package.
It's much more similar to C. The includes libraries.
This is similar to do include, yeah. And in my opinion, it's cleaner, but it's a matter of taste at the end of the day. So this is the package manager. And now that we are here, because this is something that I will do at the end, please try to, are we all in the intro folder? Yeah? So you can see that I have some packages already there installed. So please try to do add glmaki, which we will use to do the visualization part. glmaki, this one. Try add Cairo Maki. Some error. Felix, can you help here a little bit, please? What does it say? What does it say? Felix is gonna. So I'm asking for this package because it's usually large, but once we have it, then things should work.
I'm also not able to install. Is it something related to the version because I have an old version, 1.8.
No. 1.8 of Julia, you mean?
Yeah.
It should work with 1.6 even.
About the package management first, because my understanding they are downloading binary packages.
Yeah, we have binaries, but
So, how does it work on ARM architecture?
sorry, I didn't.
So if you use Intel, it's fine. How about ARM architecture? So are all the packages supported on different architectures?
Yeah, we try to. So, yeah, so there is a tier for different packages in Julia, so that there is a table where we see this is supported in this platform, and this platform, and this platform. So, and every new release, the Julia community tries to support all of them, like fix issues for all of them. But it's not always possible.
Can you enforce, because for example with Python packages you can build the package. So you can install the binary distribution, but you can compile it on the machine that you have. Is it possible to do it in Julia?
Yeah, we have a package builder for that as well.
So instead of installing, when we say add glmaki, can we enforce it to build on the platform? Is it possible?
Yeah, it's possible.
How do you do that?
There is a package for that, which is package builder. So, yeah, package builder. No, I think this is not Julia. No, binary builder, I think. So yeah, you will need to go into the docs and to start using this package to create your binaries. Doesn't work for all packages because sometimes the dependencies are huge. So yeah. So for instance, there are some libraries from Fortran that we want to use so that you create a binary for that specific library so that you can load with Julia later on. And that can be done. But it needs to be very specific to the thing that you want.
But can you have different versions of the same package installed? Is it possible?
You can switch between them. Here, I can say, that's why I mentioned, this project management is important. If you want a different version, then I will create a different one.
No, I'm asking because let's say you have a package which has a dependency on a specific Proj version, let's say 7.
Yeah.
And then you have another package which has a dependency on Proj 8. So how does it work? Because in that case, there is a Julia package for Proj, and one version is installed, right? So how does it work in that case? So the question, let's say you have two Julia packages with dependency on Proj.
Yeah.
One has dependency to
they work in both. The project Tom, right?
So I think they won't be, you wouldn't be able to install it together in the same environment.
That's why you need to separate the environments.
You have different constraints. And then the package manager will tell, I can't install this version and that version.
So
Basically, you should have either fix one of them and then just pin the version and say, I want to use this version. And then
That's
yes.
which is the package that we have to install.
Geomaki. Sorry, I closed it. I thought that we were finished. Yes.
Could you please explain again when we add packages?
Yes.
Because I work only with Python, so I'm familiar with Python environment.
Yes.
Then we install it into the environment. But here, where do we install this package right now as we add it? The general registry of packages, or?
I mean,
3, 4 different.
I think I need to go.
Yeah, but it's much more.
So when you install your package, sorry, you cannot see it. So when you do activate, you create two new files. You create the project Tom, which contains your packages, and you have your manifest, which is generated according to your computer. Okay? So, yeah, here. Okay, now I will do the things on VS Code. So activate. So this activate is activating this project Tom here. So if I add a new package, I don't know, online statistics, stats or statistics? I tried that, but it didn't autocomplete. So you see here the new.
Yes, because I think I skipped the activate part, and I am adding this package, and it's updating the registry at my Julia.
Yeah, your global environment, right?
Global environment.
Yeah. So, I mean, I usually recommend to have the global environment as clean as possible, like 0 packages there. I think I only have 2 of them. I don't have more. I only have.
It's the name of the folder that the project Toml is located in.
Yeah, I only have 4. No, 2 of them.
Global environment is called ads 1.9.
And I mean, these packages are for development. So when I develop packages, I want this revised, the thing that Felix was mentioning. If I do some changes, I don't want to close my windows and restart the environment again and again. So it does it for me. So that's why I have revised as in my general environment. Other than that, I don't recommend adding packages there, just in your environments. I think we have half an hour before the coffee break. I think we can finish the...
We have half an hour till the coffee break.
Half an hour, right?
Yes.
Yeah.
I just, while we're at the package mode, just two things for the activate that might be interesting is there's this activate -- temp.
Ah, yes. But, okay. But
You don't want to go into that?
But that's, I mean, that's a temporary environment.
So you can have temporary environments, or you can have named environments that are available from anywhere.
Yeah.
Just to add, but maybe...
Yeah, but I mean, they are not that useful. Okay, let's finish the intro. I think I will just move quickly with this part. So if you can open your notebook in Jupyter Notebook or in VS Code, you will see something like this. You should be able to see something like this. And then in my case, I just do Shift Enter, and then I can run this already. And I just did a definition for a name called Julia, and some age equals 12, which is roughly the age of the Julia programming language. Yeah, so this is to say how you define variables, similar to Python, right? A variable equals to a string, or your variable equals to a number. Yeah, that's basically it. And then if you want to explore what is the name, you click Shift Enter, Julia, right? You can do operations times 10 times the variable age, 120, or you can do a sum, similar things to Python, right? The important thing now is that you can explore what are the types of your variables. So if you do type of age, it will tell you that it's an integer, 64. And what is the type of your name? It will tell you that is a string. And you can do this for any variable that you might have in Julia. So the next part is a little bit a bit important. So when you have multiple variables, the recommended way will be to create a struct which will contain those variables. In principle, you could define this thing empty, in the sense, okay, I will do it here. You could say this is a struct that contains a name, a title, year, and yeah, a fast variable as well. So you could define this. Don't run it, and it could just work because, okay, let's try it. Okay, we'll run it, and then you call this as language, right? So you have 4 arguments. So I could provide 1, 2, 3, 4. And it will just work. I will get 1, 2, 3, 4. Let's put a name to this. Let's call it O equals that. And let's try, what will happen if I do a true, yeah, something like that. Okay, see the difference, right? So in the first one, I just pass integers all the time, 4 of them, because I have 4 arguments. In this one, I pass a string, a boolean, an array, and a number. Okay, and also works. So let's call this O. Okay. So when you do this, Julia will specialize on these types. Okay, on the type of the string, on the type of the boolean, on the type of the array, or in the type of the integer. But you can also restrict that. You can say now create a struct, let's call it struct language2, where the first entry should be a string, the second one also is a string, but the third is a number, and the last one is a boolean. So if I run this again, and let's try 1, 2, 3, 4. I should get an error because it's restricted. So you are not allowed to pass a number here in the first one. The only thing allowed here is a string. Hi. Year is a number, and here is a boolean, true or false. And then it will work, okay? So in this way, we encapsulate different variables into this object, okay? And remember, we did type of, right, before? So you can also explore what is the type of this. You can do type of OO. It's just the main struct, okay? So that means that you are creating your own types. So there are some base types in the language, which are like integers, strings, whatnot. But you can also create your own with this syntax, okay? So this is the way of programming stuff. Yeah, how to use them. I already show how to use this, Julia, right? So these are just examples that pass strings, numbers. And one important thing of the previous one is that you were not allowed, I mean, once it's created, you are not allowed to modify that struct. But for that, we have, which is called the mutable struct. So you can define something similar. You can run it again with different arguments. But now you can mutate the different fields. In this case, we can change the title. And now you should have here Python, whatever, right? So this is the first part, like strings, types, mutable structs, and it's the basics of the basics. Other things that might be useful is booleans in general. So I can always say not true. So the not true is with this. Okay, not true. Or you can say true, right? You can say true or not true. You can do a combination of false and true or not false. So what is the output? True. You can change this to true, false, okay? So these are things that are very well known in other languages as well. So I'm just showing what is the syntax here. You can also ask for things. You can ask, is 6 an integer? And is 6 a real number? And you can do that assertion, right? You can also ask for things. You can ask for equality, 1 equals 2, less than or equal to.
Why is the real one true?
There is a hierarchy of numbers. So
basically, in Julia, you always have a tree of types. So you have different abstract types, and then in the end you have a just normal type, and then the actual type, and then so basically an integer in int64 is an integer, is a subtype of real, is a subtype of number, is a subtype of any. So when you do this type of, if you would do now type of,
let me do a little bit more of this.
type of 1.
So in Julia, we have this called thing hierarchy. So we organize things on types, on different types. So you can say, this is the outermost type. And from that one, you can restrict the next ones. So for instance, you can say,
so it's like typecasting. So in SQL languages, you have
I'm not familiar.
typecast that you have, let's say, a string, you can cast to an integer or
No, it's not typecast. It's more it's subtyping.
subtype.
It's
So it's
subtyping.
abstract subtyping.
Yeah.
So maybe it will be a bit clearer after you did functions and multiple dispatch. No.
It will come, yeah, probably come later. But the main point here is that you need to think about the types on Julia in a hierarchical way. So
Okay, that's clear.
that's clear. So,
So
and
maybe
the
you can-
outermost is real. For numbers, is real.
It's number.
Or any.
No, yeah, okay. I mean, you could just do subtypes of real. And then maybe it would be clearer.
Sub
Should be
types.
subtype. I think so.
I
Maybe
don't
it's
think
base dot.
Real.
And now you see there's a abstract float, abstract irrational, an integer, and a rational. And so basically you go down this tree, and you can look at this from either from top to bottom or the other way around. Or you can also do super type of.
Yeah, that means
So
what are the
biggest are the rational and the integer are part of the rational?
No, so basically the highest level is real.
highest? Yeah.
Under that there's abstract float, abstract irrational, integer, and rational. So they are basically next to each other. And underneath the integer you have, again, no signal. You should just, okay. You have Boolean signed and unsigned, and then under the signed you have the normal integer in 64.
So you can always go down and down or up and up.
Your HDMI cable is loose again. That's all.
Ah, sorry, I was typing a lot and you didn't. So
Yeah, it's just no. Yes.
Is it computationally more efficient to use the lowest data type than in Julia or
No, it's basically more used in functions and multiple dispatch to decide which code is actually run, depending on.
So you can always go this tree of what is the subtype of your type.
There are
but
conversion
yeah, that's
rules
basically
between
it.
certain types.
In general, if you have reals, I mean, because if your type is real, you are in the outermost boundary of your numbers. So in my experience, if you are at that level, you will pay a price in performance.
No, sorry, it's not like in C that you use more digits for representing that number.
And
No,
that,
it's more a question of whether this is an.
no, for the
Like the int 8 till the big int, there are more.
I mean, in this case,
Hardware you are using more.
in this case, you have the number of digits, yes, in this one. So, but yeah, that's a subtype of a number that is
Can
signed.
you just go ahead and show the functions and multiple dispatch examples, and then
Yeah.
maybe we can explain it from there.
Maybe, no, but I think the message is clear. You have a hierarchy of things, and then you move from there.
Yes, but multiple dispatch will make much more clearer where this hierarchy is actually used.
Yeah. Okay, let's try that then, because this is the next session. Can you see the screen? Yes. So the next step, we have 10 minutes, I think we can finish, is the definition of functions. So there are different ways to define a function. You can do that inline, like here, your function name, your different arguments, argument 1, argument 2 equals the sum of the two, right? You can do it that way. You can also do function, the name of the function, the input arguments, and what is the thing that you are returning from that function, okay? You can do both, they are the same. Or,
Sorry, and what if argument 1 is a string and argument 2 is a boolean?
what do you think will happen?
Yeah, what will happen?
That will fail.
That will fail.
That will fail. So and it will fail, and then you have to handle with that, like in object languages with an error.
But is
So
but
here
is-
it will
is-
fail in the plus function.
Okay, let's say, okay, you call that function
Yes,
in a.
it's called f name, not function name.
You are are calling that function.
Ah, no. Yeah.
And it gives an error.
Yes.
Yeah, but
That there's no plus. And now it gives an error that there's no plus. For
because
string
there is
effect.
not a method that is defined for that operation.
How you handle the error? How you
Uh,
handle
ha-
the error?
no, but the error is like, does it make sense to define that thing?
What do you mean by how?
I mean, you are writing a bunch of routines.
Yes.
And in one code, you put this string plus boolean. String
Yes.
plus integer. So how is the error handling?
You can see the error, and it says that you cannot do that because it's not defined. Okay?
I mean, you could do try catch, but here now you could, maybe just go ahead a bit more. Yes.
Okay, that's the error. Okay.
You have an error message.
Trace makes the compiler all these messages.
Yes, the compiler says this is, so it says method plus not defined, and then you see where it's actually coming from.
Yeah, it will tell you exactly where it's coming from. And closest candidates, this is important. I mean, sometimes the closest candidate is like, I put the wrong input argument, so it should have been something else.
You just see that this shouldn't have been a string, but something else.
Okay, important part of the message is how you define the function. You can do it in one line like this, or you can do function, name of the function, then the arguments, okay? And we'll go back to that one.
Sorry, and typing the lines, typing the commands and so on, you have some syntax.
What commas?
In Python,
Yes, you can type the.
tabulation and so on.
He's coming to the types. Typing.
No, he means like
Oh.
this.
At the top, that 8 character. So if you have you define the function,
Yeah.
underscore name, and so on. And the return, if the return is at the beginning of the line, that's also a.
Do you mean if it, okay, you mean if it's here, this thing?
Yeah, syntactically, yeah.
That's the same. There's no white space.
There is no, yeah.
There's no relevant. I mean, there's
Yeah.
sometimes. I mean, there's certain things, but normally there's no syntactic white space. I mean, you shouldn't put a
Here-
white space between the function name and the
You should have it like
colon
that,
and the
but
brackets.
you also don't need to worry about this or this. So, yeah,
No problem.
yeah. You can include it here, but it doesn't matter, doesn't do anything. So you just don't see that function definition.
Yeah.
But that's it. What else? So you call the function, you use the function. And because the function is defined without types, so that means that for numbers, you can pass integers, 1 and 2, and you will get a 3, which is an integer, right? So you can ask for the type here. It's an integer, or you can ask for the type here. So it's important to notice that this function is now specialized to these two methods. So the compiler already has optimized versions of the function called f for integers and floats. We can do methods of, or just methods?
Methods, yes. There should be one, right?
It should be just one because it's the one that is.
Yeah, it's just you only defined one
One
method with any.
Yeah, but the dispatch is already working here. And now this thing about the types. So you can do the type declaration for the arguments. I mean, similar to the definition of the struct. So if you say that the first argument needs to be a float or an integer or a string, you can do the same with functions. And that's basically it. So you pass here. Yes. A default value.
Just equal.
Like, give me an example. Like what?
You could in your f example, you could just do f of x comma y, x x comma y equals 4 is x plus y. No, in the bracket. In the bracket. Just
What?
do an equal y equals 4 in your
Ah,
bracket.
okay, the default values. Okay,
Then you
okay.
have a default value on that.
You mean this?
Yes. Yes, and then you can do f of
Function round number, for example. Yeah. The first time before the return, if you put more algebraic.
More things here?
No, one line higher, you insert. After doing 6, okay, insert a new line, and you make other
Things.
things.
S equals x square plus x, you mean, like that?
Yeah.
Then return x, s.
Okay, but that.
what's the question?
You need an expression where
You can do that.
put some.
So, I mean, the definition of functions works the same. And you can do several lines, operations, and then the only thing that you need to take care of is what is the return value.
But
Okay. Okay, let me finish this before going to the break. So yes, multi-dispatch. So what was here? Integer and rounds. So here it doesn't matter what you pass. So if you pass a float, you will round up your number. But also if you define it for an integer, it will also work. So if you do round of 2.1, it's 2. But if you do round of 2, doesn't make a lot of sense, right? It's also 2. So just that it doesn't break. Let me just show you why this is important.
also,
If I call this round number, and then I say this will be float 64, and then I do round to of an integer. So what will be the output? Should be an error, because there is not a method definition for this function where the input is an integer. So let's say you are designing a pipeline of analysis where you can pass integers and float numbers, but you want things to work for both cases.
Will it work if you say instead of float 64 real? It will work, right?
Yeah. Real. It will work. But because it's a subtype, right? Real is a subtype of integer and float. So that's why it will work.
but to add, actually, I mean, the more the more interesting example is taking 2 inputs, because what you're now showing is single dispatch.
Yeah, a single dispatch is just one, but do I have 2 inputs? No, I don't.
You should.
Multiple return values. I have this one, which is real. Yeah, which also will work, and anonymous functions. So Felix, can you take this for a moment? I need to run out of this room for a few seconds. Can you do the multiple dispatch for 2 arguments? Here, please.
Can I do it on that?
Yeah, do it here.
Yeah, so what we just saw is a single dispatch that basically here we saw that the function that is called depends on the input type, right? Whether this is a float 64 or a float on integer. But now we could also use this f. And now if we would do f of x in 64 equals, let's say, y. If you do it like this, now we see, let me add a new code. Now we see the methods of, there's a new method of f. No. So we have this f of x int, and f of x, and a function where you can have any type. And now what would happen if we do f of 1002? What would you expect the output to be? So in this case, this will just be 4, because we defined this as, if it's both integer, then it just returns 4. But if we would do one of them, make one of them a float, this will go back to the definition we had earlier, where it's just the sum of the two inputs. And in contrast to Python, so Python does only single dispatch. So basically, which function is going, or which method is going to execute, depends on the type information of the first input. In Julia, it depends on the type information of all the inputs. So you can have, so here you see that this changed which method of is called depending on the second input here, and that's heavily used in the Julia ecosystem, that you can have multiple inputs, and then depending on the type, it changes what's going to happen. Yeah. I mean, I think in the beginning it's good to know. Yeah.
So do I understand it correctly that it also doesn't override these functions, but you can define multiple ones with the same name? Is that right?
Yes. So basically, in Julia there's a distinction between the functions, which is basically this is the name. So f is the function, and then here we did this methods of f, and then you see there are 4 methods, and they are not overwritten. So you would override them if I would do now here.
So depending on the input parameters, it chooses the correct function then?
The correct method then, yes. So if I now define this as equals 9, and then we see this actually overrides the method, because I defined the same function with the same type arguments. But if I would do,
And put a string there, f1000.
if I do a string here, like this,
No, in that function.
here. If I do a string here, wherever the string is in Mac. So if I do this, it complains that there's no plus function. But if I would now define a function that says just take y and what's it? What? And then now you see that, first of all, we added a new method. Here we added a method that depends on x and on an integer and a string. And now if we run it, we say that this just returns s. So it just returns the second argument. Yeah, and I think That's it, and we start with the raster data handling after the coffee break, right? Or are there any urgent questions or urgent things you think we should still?
No, I just want to, if everyone was able to install GeoMaki
Yes.
before, so if you go to the bottom of that notebook, you should be able to see, yeah, there is more material that you can take a look later if you are curious about it. But if you go to the bottom, you will see that I have this package status. So you can see your environment as well, again. So this is just to recap.
Yes.
So remember that we were talking about the project management with package, right? So you can do the same within the notebook, within the Jupyter notebook. So you can, you need to start saying using package, PKG, and then package status, and then you will see your current project term. You already did this, package.add, and then the name of the package.
Can you show them to?
Wait. And then usually you say using GeoMaki, activate. And this is just an example to show you how to do a scatter plot in 3D. So you will have an array of points with different values for each point, locations of the points, and a different alpha color for those points. So just run this and run the last line, and this will give you your first plot with Maki, GeoMaki, which Felix will be doing a lot. He will be doing a lot of plots. So this is the library that we use to do our visualization. So once you do this, you should be able to get this window, which creates the plot that you want to visualize, okay? And that's basically it.
Yes.
For this session.
I want to.
I need to finish because it's coffee break.
It's coffee break, right?
Yeah.
Okay, then we instantiate the package
Later. Yeah.
So,
Yes.
I have to leave, that's why I'm asking. So,
Yes.
at the end of the session, will you put the notebooks back because the example notebooks are empty? So you will put the full ones, right?
The ones that are missing from Felix, yes.
No.
Which one?
I checked the ones that you put. Actually, these are like templates on. So there is one about raster data which is empty. So
Yeah, we were going to fill it
you will put
during the
that-
session.
You will publish back, right?
Yeah.
Yeah.
We can, because you can't be
I
here.
need to go to other session. That's why I'm asking. So
Yeah, okay.
Yeah. I can. So the idea was that we're going to work through a few examples,
Yeah,
and
together.
everyone is just going to code along.
Yeah.
So we just do it hands-on. But I can just push the final version that ends up on my computer,
Yeah.
Would be very nice.
so that you can just see it then.
Okay. Thanks.
Or there's also another data tutorial or more showcase, which I did 4 weeks ago.
Mm.
I can also show you or send you the other notebook.
Okay, thanks for your attention for the first part of the session, and yeah.
We have a coffee break and we convene at 4 o'clock.
Yeah, and yeah, you can ask me anything. I mean, coffee breaks and in the venue, I will be here the whole week, so there will be a chance to talk about it. So, yeah, thanks.
And so my plan for this session was that we just go on and do really hands-on without me showing you much of the stuff, just doing the things together. So, and in the repository you downloaded, there should be in the main folder, not in the intro. I should do the. There should be this hands-on ESDC and hands-on.jl files. So we are going to start with the hands-on ESDC. And now to install the packages that we need. You see that we have this project toml where all of the dependencies are listed, and we have this manifest toml, which lists the dependencies and the dependencies of our dependencies, and so on, with their actual version. So to now use this, you can do instantiate. And then it's loading the packages that are actually specified there. And this is also quite nice for reproducibility, because you can just send a project toml or manifest toml to a colleague, and then they will get the exact same environment you had. If you instantiate, it will download the needed packages. Or if the packages are already installed on your computer in another environment, it can reuse the code that is already there in your .julia path somewhere. So Julia is going to share all of is going to share the code of the same version of your dependencies across environments, but then it registers that this environment needs this and that version. And then, yeah, that's specified inside of project.toml. So here in this case, we only specify which packages we need, but in actual packages, there's also a compart entry, which specifies which version of the package you need. So I hope everyone has instantiated the package or the environment.
If I don't get anything,
What do you mean, don't get anything?
you get instantiated without any error, without any string.
Then try st to see whether it's already installed the packages. I mean, also, can you help?
Because maybe
I think you should make sure that you are in the BiDS'23 hands-on environment.
Yes. Yeah, if I just did the instantiate again, so if all the packages are already installed, then you don't get anything. Yeah, then you would have to activate the BiDS'23 hands-on. So I'm not sure in which path you are. You might be in the you could also do activate.
Yeah, now instantiate.
Yes. So basically, no, instantiate is, you have this in your project toml. You have this list of packages. So basically, and then if you do, so now you can't see it, but you can have this, if you do st, you can have a small red arrow next to the package name. That means that the package is not yet downloaded. So it basically says instantiate is basically, so we can just do read the help together, but basically it just says download all the dependencies for this project, for this environment.
And then they will be already finalized
Prepare for
next time.
What?
and prepare for to be executed.
Yeah, and then prepare.
Commands.
Yes, this is like you have to first download all the packages that you need, or
Like a library link.
yes, a bit like that, but from the net. So it's sometimes it just needs to download the data, the actual code from outside. So that's instantiate, and the other one is resolve. Is if you're stuck in certain dependencies, you can resolve the package dependencies, and it tries to update. Yeah. But as I said, the nice thing is that if you have a fixed, so because I just gave you a project.toml and a manifest.toml, you should now have the same versions I have installed previously, also installed by just doing this instantiate. So you can be sure that this is running the same code we do. So yes. So I hope everyone has installed the. And now we go on with the hands-on ESDC file.
So sorry, and now you call the.
And now I'm actually loading the packages in this other example. So here I'm using Shift-Enter to run this line of code inside of the wrapper, which is done by the VS Code Joomla extension. And now it needs to precompile some data. And we can do the same with GLMarky. And now the example data that we're going to look at is the so-called Earth System Data Cube, which is a predefined data set of Earth System variables that we provide at the institute. So I think that the path is not that relevant. So we just we can just basically you can more or less ignore these 3 lines. And also normally this set open, so this one is normally not necessary. You can just, if you would have any ZAR data set, you can also just do normally open data set of path to my data.zar. And then it will open it. This set open is only necessary because of the specifics of this data that we're using as an example.
These open data sets are precompiled data sets.
The data set we're using is a precompiled data set, but the function open data set can be used to open any ZAR file or any. No, actually any. So this is a function. This is the function coming from Yax arrays. This is the package for. This is similar of. So in scope, it's basically X array plus task in the Python world. So you can use. So you can use the open data set function for loading any data, basically any geospatial raster data. Yes. So, and for TIFF, so it depends a bit. So if you want to open ZAR files, you have to load the ZAR package. If you want to open netcdf, you have to load the netcdf package. And if you want to open anything else, then you can just use archgdar. There's also this package called, I haven't installed it yet because we are not going to use it, but this is the Julia wrapper for GDAR. And basically with that you can open any TIFF or env files or whatever. So all of these different files that are possible in GDAR can be opened by that. Yes?
I was trying to run these commands, but it didn't install these packages when I executed instantiate. Is there maybe something missing in there? Because it seems to be in the tunnel, but
So who's seeing that? Okay, where are you stuck?
I'm in the terminal. I instantiated, but
The Jupyter, so in the Jupyter notebook? I don't have an example here. Wait. I think you should just use the package manager directly. So you can do using pkg, and then you can do pkg.activate off. And then, so basically there's this, sort of for the package manager, there's the REPL. So this REPL mode where you just do the square bracket and then do it directly in the REPL. Or there's the function mode usage where you have using pkg and then you do pkg.activate off and then the path, or pkg.instantiate, where you basically can all the same things but directly as a function. And that's what you can use in Jupyter notebooks. Or what you can also use if you have a long-running Julia process, which you don't want to start from your REPL. You want to, basically, if you want to have a script that's going to process a large data set, you can also, in the beginning, do using pkg.activate off, and then to make sure that you're actually using the project you're supposed to. So, who managed to run the packages? Good. Oh, then just do add ZAR. So for some reason, apparently, I'm not sure. Maybe I just... Okay, yeah, yes, ZAR package is missing because it was not missing in my thing. Yes, you should also do an add ZAR, and then what's that? So now can we go on or? Okay. So basically now this DS is a Yaxo data set, which is basically a collection of data cubes. So, and the difference between a data set and the data cube is that in the data set you can have cubes of different dimensionality. So you could have a latitude, longitude, and time series data set parts of the data set, but you can also have data cubes in there which have are only static and only have have no time dimension, basically, or have.
So it's a two-dimensional or more-dimensional?
It can be multidimensional, but and here you see. I think here in this example they have all the same axes. So here it says shared axis, and then there's a longitude dimension, a latitude dimension, and a time dimension. And but then you could have variables that you could theoretically have a variable which is only longitude, latitude without time. For example, land cover or soil property or something like that. So in this case, we have this data set, and then we can convert this data set to a data cube by just using the cube function. We could have also just done this here and just do cube of Z open or just cube of data passed to the data. And so basically this converts everything to one cube, and now these different variables that we had earlier are now also in their own variable dimension. And here you see it's a very coarse spatial resolution, just for this example, so that we don't have to download that much data. And then it's 989 time steps and 42 variables. And so you can have a look into, by just doing ds dot and then tab, you would get a list of all the variables that are in the data set. Or we can also if we look at the cube, we can now do subsetting. So there's different subset possibilities. So you can just do longitude equals, and then there's different selectors that are possible, which are so you can have at, or in at, near, or between. So at would just would select the specific point in this dimension. Near would take the nearest point on your axis in this dimension, and between would take an interval of everything which is in between. And there are more. So there's nothing, and then here you can also again look at the help to see, okay, what is it actually doing? What should I know about this? And then here for the cube, we can just do cube on ti equals at of not in my data set? Ah, okay. Now you see that this at does not work because this timestamp is not in the list of the timestamps. So maybe I don't care much about this actual date. I just want to have it on near this date. And so you can use this near functionality to actually select certain things, or you could subset your a certain region of interest by providing the longitude. Unfortunately, I don't have nice longitude latitudes in my head, which are relevant. So yes, and what we could also do, wait. Okay, I have to look at my cheat sheet to actually, so we could now, the idea was to subset the temperature functions. So this where is basically applying selecting on this function that I'm applying inside it. So you see this contains is a function that checks whether this word is in the string, or you can just do contains of some search keyword. So basically contains of temp gives you a function that you then can apply on. This is temporary, or I mean that's what we're going to use it for, and that's what we're using in this where selector here. So we can just select everything, every variable that contains the part temp. Or we could do this. And now we see that we went from 42 variables to 3 variables. And so of course we could also, now we see the different variables, we could also just do, if we're only interested in a certain variable, we use this. And now we went from a 4-dimensional to a 3-dimensional data cube by discarding all of the other variables that we're currently not interested in. And now we can give it a name. And so what's important here is that the subsetting is all happening on the metadata level. So currently we're not touching the data at all. So we downloaded the metadata of which variables are available, how large is everything, what's the type. Then we constructed this dataset or data cube. And now basically doing this subsetting is not touching the data.
How is the memory usage?
Why is that not working? No, it's not var info, it's summary size, right? Yeah, we can look at that. That's currently the memory. So it's basically just, it's only holding the metadata information in memory. So even if you would have a much larger data set, what I'm doing at the moment is not loading the data into memory. So it's just subsetting it, and the data is currently
They are just pointers.
it's pointers to the actual data, and the data we are looking at is located in our cluster at our institute in Jena, in Germany. So it only downloaded the metadata, and now as soon as we subset and then do some computation on it, we will start downloading the data.
Subset computation is made on your computer.
The subset, this is only basically computing the metadata
On your computer.
on my computer. It's just checking,
And on your computer during this one,
there's nothing happening. It will only start happening as soon as I say compute something or plot this or save it somewhere. Then it will start computing. And
if I want to make a pixel arithmetic on a huge data set.
what do you mean?
A pixel by pixel. So
Yes.
it's a terabyte image.
Yes.
It's not big.
No, it's only going to load, so you can specify basically how much memory your process is allowed to take, and then it will only take this amount of memory and tries to download only the chunk. So there's the, I mean, this also depends a bit on the chunking of your data set, how much memory is how much of your data is bundled together. But you could, in theory, have a very huge data set that is, this is only loaded partially into your doing your computation. Yes.
So if I have loaded some kind of data into Julia, so if you would something have this indexing in Python, it would actually override the original data array, and you would have to have this like .copy. Is that, how does that work in Julia? Like, is it, if you do some kind of computations throughout your script, is it then overwriting the first
No,
variable?
the input. No.
Yes. I mean, it depends on how your, so here,
Function.
how you define your function and whether you override. Yes, I mean, there's, so normally Julia is copying all the data, and to not copy, you need to use views, so that your data is actually only viewed and not copied. But then you can use this to either overwrite it or not. So, but normally it's just, in Yaxarrays it's normally just read out of the data, out of the memory, and then you do some computation, but then you don't write it back into the same file, but you write it somewhere else.
And how is the data pipe between, let's say, so it's a normal like a FTP or HTTP process?
It's HTTP.
HTTP process.
Yes.
The protocol between, so it's erroneous.
What?
It could be erroneous.
So here you see that this is HTTPS, right? Depends a bit on your real setup, and I mean you can also use it on your local machine and then just use normal file access.
But you don't use terabytes of images on your local machine.
But on your local cluster, sometimes you do, right? Depends on use cases and so on, but yeah. anyway, do you have a? Did you follow along with the AirTemp? So everyone has an AirTemp data cube. You have a question?
How do we read geospatial metadata?
What?
How can we read metadata, like geospatial metadata? Like resolution, projection, or are those two values?
This data set. Wait. That's a very good question. This should be a meta. Okay, so there's a metadata function for the data set. Unfortunately, my example doesn't have any metadata, so or it got lost somewhere, I'm not entirely sure. That's something, yeah, metadata handling is not as good as in other languages, I think. I think sometimes we drop it or we don't follow it through during the processing pipeline. There could be some improvements on metadata, automatic metadata handling. I think that are currently not done. That's so that you would actually make sure that the metadata is properly.
You mean is not so good on your metadata handling in this process?
Yes.
In this.
Yeah, in these packages and.
So we can define another package and okay.
Yeah. And so now we want to. Now we want to look at one data set or one. What? Oh, wait. Never do live coding because you could do something stupid. So here we just select the 30th of June for our air temperature, or actually we select the newest point in our time series to the 30th of June, and now we can do I should have given that a name.
So the newest before.
The newest.
The before.
Not necessarily. No, I think it's just the closest distance. Because it's basically the same, also the same function for longitude, latitude. That also makes sense. So, yeah. Oh, good question. Whether you can force it to
Because
actually use the.
Some process is important.
Yeah, it might be. And so we just gave it a name, and now we can plot it with. Yes.
Is code available if they are? Do you have the notebook or something?
No, I'm just. Should we? Should I make it that way? I mean, So my idea was that we just go through it together and just live code it here. But I will upload the final version at the end. So basically I would say I will live code it now and upload the final version that we want to.
Where you upload to GitHub?
Yes, to the same repository. So that at the end there will be some, at least some code available for what we did today, right? Yes, I can also upload. Should I upload the cheat sheet now? Okay. Now the good question is, yes, I can. So that's a Jupyter notebook with at least some of the code that I'm. So you can. I also just copied that now, but wait, not that window. What? Here. That's where I was, right? No, that's not where I was. So we just saw that we have the seed map. So, so basically that's the average air temperature for June 23 globally. It's not that interesting to look at, but now we see that the range goes from 0 to, or from plus 30 to minus 60-ish. And now we could do, wait, no. And now basically at this point, because we had to plot it, we downloaded the whole, we accessed all of the data, so we downloaded the data now. But let's say I want to convert this to Kelvin. I can use this map function, where I can just basically apply a function on every element of my data cube. And here I just add 273 and then do it here. And here this is also just doing, so the map function is only happening in memory. So this will only happen once you download, once you plot the data, save the data, or do more complicated analysis on it. And and now we could also plot it, but basically the only change, we can just plot it, but the only change that we see is that the color bar changes from going from 220 to 300. So it's just changing the color bar but that might be handy for other things if you want to apply one function on every element of your data cube. And we could have done this also on the air temp data first and then do the subsetting. So basically it's just applying it everywhere. And then another another nice thing to do is this map slices function. So we can do I'm not too sure whether so this skip missing function just skips all of the missing values. So there's missing value similar to the NA value in R that indicates missing. And now I want to apply the mean over the whole time series. So I do and now this is not working. Otherwise, it's not working.
What's that symbol after the mean? And mean skip missing, and then there's a dot.
This is a circ, so it's basically function application. So it's taking skip missing and then the mean.
Can I also use a different symbol?
You can also just do. Wait. Actually, normally you just do. You can either do this. Or what this is similar, this is the same as x2 mean of skip missing of x. So it's basically just first apply skip missing and then apply the mean.
So does that actually support LaTeX commands? Or? Yeah.
Yes. So it supports LaTeX REPL computation completions. So you can do slash, and then also if you need Greek letters or something like that.
Do some. Alpha, beta, gamma.
And then you can also, if you don't know how to type a certain symbol, you can also do help mode of alpha, and then it states how you can actually get the symbol in the REPL. So
So it failed, right?
it failed, yes, because of time.
Using statistics.
Okay, now I'm just. Okay, now that works. So this is taking some 30 seconds or so. And this is now this is doing a map slices operation. So it's doing the operation on every time series. So it's basically, yes? What?
Yeah, that you need to do using the statistics, otherwise they will get the same error.
Yes, and then basically doing that. Okay, and then we get the average. So it's basically the average time series, the average air temperature over the whole time series that we had. And so you could also change this to do latitude. Should have named it differently. Anyway. And now we could do. Okay, now it's not. Yeah, because. I mean, now it did the averages on the latitudes. So now we have a time by longitude plot of averages across latitude. Maybe doing this across longitude would have made much more sense. Yes. Yeah, you basically see the seasonal cycle in certain things. But yeah. And then for more complicated analysis, there's this map cube function, where you can map a given function on a cube, giving inputs and output dimensions. So you can specify both the input and the output. So you can go from, you could either just do time, or you could do longitude, latitude, and then with that you could do a plot of, so we could do input dimensions are what? Wait. What?
The high threshold notice. Right.
Ah, that's, yes. And then we specify that there's an empty output. And then we can do in the input dimension, output dimension. And that basically converts our global map into one point, and then we should why? Okay. I should have followed the script a bit more. Yeah. So I'm currently not sure why this breaks. So about that. Here's my window. So, but yeah, you can basically combine either multiple inputs, or in this other example we had, is you can also basically, if you want to normalize your time series, you could also get the normalized time series back, but also keep the mean and the standard deviation. And so you can specify multiple output dimensions with those outdims. And then you can just say, okay, you can also, and then you can have different keyword arguments for the output, so that you directly save it into a place you want to keep it in, and yes, and then do that. Or you can, another thing that's possible with Yax arrays is that you can basically you can also do moving window operations, by just having this. Oh, okay. This as an input, this moving window, and then you can specify. You specify how many steps before and after in this dimension should you take for every input. So in this case, this would be a 3x3 window, and then you can apply any function on this inner matrix that you would get. And I think, Lazaro, do you still want to do your plotting examples?
No, depends how are we? Tired? Yeah, let's just do the last cube and that's it.
What do you mean the last cube?
Yeah, the last example.
Yeah, I just want to mention one thing. So I need 2 more minutes, but so basically, I mean, we could. There's multiple examples where you can do this, but one nice thing to mention is that we could also do interpolations, but I wanted to mention, where is it? No, not that one. Here, using Python or R. So if you would have an analysis that is already done in Python or R, and you only want to apply it on your as an inner function, you could use PyCall or RCall to easily say, okay, this is my function in Python that is, for example, a time series analysis. I just want to apply it on every pixel in this large data set, and then you can import any Python package dependency and just do this as an inner function. And the other thing that I wanted to mention is that's at least, yes?
So then the same speed as if I would do the computation in Python, or is it somehow converting it to Julia? Is it faster then?
I think that a bit. So it's basically you're switching Xarray and Dask to the Julia package, which might be faster in certain use cases, depending on your chunks and on your actual setup, because Dask is sometimes failing to even process the whole processing graph, and this might be then faster in Julia. But I mean I would really like to see some benchmarks or do some benchmarks on comparing this, but yeah, we didn't come to that yet. Yes.
Yeah, in the same line, there is the sklearn Julia package.
Which one?
The sklearn Julia package that is a binding for the sklearn Python.
Mm-hmm.
So is then the computation done in Python or in Julia? And if yes, do we need to gain speed and processing time?
That's a good question. I mean, I think sklearn is then the computation is done in Python. I think yes. Yeah, I think that's just a wrapper. So in this case, if you would do this with PyCall, basically your inner function is done in Python, or most likely it's going to be done in C or C++, because then basically you're wrapping your C most inner thing, which is C or C++, because someone already speeded up, into Python, into Julia, and then run it. I think what this could give you is that like only this application across all the different pixels would then be done by Julia, which might be able to speed up certain analysis. And I just wanted to mention that the Xarray package is built with speed in mind, so it's like and very easy to parallelize. So all of the things I showed can be made parallel by just doing either starting Julia with number of threads, so you can have multi-threading by just starting your Julia process with Julia minus T and then the number of threads you want, or Julia minus T auto to just use how many threads there are. And, or you can just use it by just adding parallel workers. So here we could just use distributed, which is the standard library for distributed computing. And then you'd say add procs of 4 or 40 if your computer allows this. And then you have to make sure that you load every package that you need. And by using this add everywhere, so add everywhere just runs the code that is inside this begin end block on every node. And then after the setup and making sure that so basically making sure that all the packages you need and all the functions you need are, so also your inner function is available on all workers. You can simply start your mapcube call or your map slices call, and then it will be parallelized wherever that is. And it's also taking the data structure or the memory structure into account. So it's always trying to load the chunks on block so that it tries to load only every chunk only once, if possible. I mean, yeah.
In this array, I can define the chunking, like which dimensions should be chunked. Is that also possible in Julia, or is it being done automatically?
You can. I shouldn't have done that.
You can define your own chunk.
So, I mean, there's a chunking that is on the data, right? There's a predefined chunking from your disk, because your data set, someone saved the data set as a certain chunking, right? But you could use this set chunks function to define to re-chunk your data, and then you can combine this with the save cube. So save cube is the function to save your data or your data cube. So you can do save cube of set chunks and then specify a chunking as a tuple of just, okay, I want these chunks for all this, for these dimensions, and then it's going to chunk the data in the specified way. Yeah. Okay, are there any more questions? Otherwise, I would go hand over to Lazaro to do some nice plotting, as in.
Just one, but just to close the session.
Yes.
So I already uploaded the notebook. Okay, it's not a notebook, it's a script, but either way, it should work. It's in the same folder as the one in the first session. So if you download the repo again, you should have it there. Or you can just go there, click directly on GitHub and copy paste the code into a new file, whatever works. I think I need my charger. Before showing the plot that I want to show, I want to make clear that, okay, not make clear, but more like ask for your help. In general, like, please open issues on the packages if there is some functionality that we don't have or that you might like to have. So yeah, we are really open in that regard, so that if we don't know what you need, we don't build it. So, and for instance, for this chunking part, there is the documentation. You can go here in the documentation, take a look at how the chunks are done. How can you define your own chunks? How to extract the data, the chunking. Yeah, so everything related to JAX arrays in this case, which is the package that Felix was using a lot, is documented here. I mean, we try to do our best, but yeah, we don't know all the use cases.
Just to add, not only add issues if you have missing functionality, but also if there's stuff that could be explained better in the documentation, or which is just not working.
Yeah.
Because I mean, there are some rough edges, and there's only some time, so yeah.
Yeah, thanks. So, yeah, please do. I mean, open issues. As for the last part, I will just do a very simple version of a data cube. I already share the data. The file is in the folder that I just push. So that's why I say you can download the repository again, and then you will see, you can just copy the file, which is this netcdf file, and the code. So it's just, yeah, 20 lines of code, not much. So that's, I wanted to finish fast. Yeah. So the idea is to use the same packages as before: GeoMaki, JAX arrays, netcdf, dimensional data, all the things that Felix was talking about already, and just loading your netcdf as a cube. In this case, should just hopefully work if I have all the dependencies installed. And in your case, you should be able to do the same. And it's not working. It's not working because, why not?
Where's your hiding?
Yeah, it's because I don't have the current path. Sorry, I need to fix this on the fly. But yeah, now it is. So it's a simple cube with some time dimension, some x and y dimension, which is longitude, latitude. And we have two variables here, which is NDVI, target, NDVI prediction. So this data cube was prepared by Claire Robin. She's a PhD student at our institute. Yeah, she is mainly interested in vegetation. So that's why we have NDVI. So this is the output from some COM LSTMs. But yeah, here we are only plotting the output. So I just did some pre-processing steps like longitude, latitude, and some appropriate scale on the time dimension to have a nice cube, which is line 9 and 11 for the time. And as Felix was mentioning before, okay, I will just run this and I will get the numbers. From your C cube, you have different variables. You could select target or prediction. In this case, I just selected prediction. And then you just extract that variable and the data. For me, it's easier because you can fit into memory here, so it's not that big. And just as a simple test, I can do a heat map, which you just pass long lat and the value. So that will be my default heat map, right? And then, because this is it's an array that contains time, longitude, and latitude, so you have values in all directions, right? So there is a function in Maki which is called volume, which can plot that easily. So it's just a simple line like volume. You just pass the time axis, longitude, latitude, and the array of values, and your color map if you want to do fancy stuff. So I just select these lines, and I should get this kind of cube here. So it's an easy way to explore your data in a few lines of code. So just to explore how your data might look like. And as you can see here, you can change different parameters, right? Like, so we have, I think we have like 800 different color maps, so to choose from. But yeah, so you can. But I like FASTI for vegetation, so that's why I'm using that one. So this is the primitive function called volume, but you can also do a contour. So the volume will give you insights into the inner parts of your data, so you can have some transparencies and see how things look like. And the other one is contour. So the contour will do a more solid version of that one. So you will have, yeah, a solid version. So you only will be able to see the faces of your data. And that's basically it. I mean, this is the most easy way to do it. There are other versions out there, and we can also do it here, which is you could pre-process the faces as images and then just stick them together into the cube, right? So that would be the other version. And that version can be achieved also here, but for that we need a little bit more of work. Yes?
For those cubes, can you control the interpolation between the time steps?
No, for these ones, yeah, exactly. For these ones, you cannot. Yeah. Yeah. For that, we will need to do a different version of the cube. That's why I was showing the different ways of doing it. But yeah, for volume and contour, you cannot. I mean, you can control the levels here, but it doesn't look that good. But you're right. You cannot control that. The interpolation. Yeah, you could. Yeah, but that would be a pre-process step, but not within the function call of plotting the cube. Yeah. Yeah. When we talk about time, I mean, I usually have versions where I plot each pixel. Actually, like I actually want to see how things look like for each time step, so I do voxels basically. So that one can also be implemented. I will share a link at the end of this session where you can do that. Yeah, the last version is to stick, apart from that one, is to stick the images into the faces. For that one, we have this version. So, okay, yeah. It's already done, so you just can use it. Where you can pass a list of colors. So this list of colors can be also a different image, so a different face of the cube. So this is just for, yeah, teaching purposes, but you can run this, and then you will have a matrix of colors, and then you think of this also as a matrix of images that will go into each face, and then you plot this with mesh, and this mesh will give you a cube which has different colors in each face. And this face, each face could be an image, okay? And this is where I leave this. If you want to know more, or to finish this, there is a complete tutorial on how to cube. And yeah, so you can start here. There is, okay, I have this web page which is called Beautiful Mackie, where I have a lot of examples on how to do stuff. And one of the sessions is how to cube. So you can start from simple meshes, do wireframes, meshes, put images, and then, yeah, you see the example how the image looks like if you do the normal mesh, or how you can put each image in each side. And the last example is you actually, oh my gosh, you actually use the images. So in this case, I did an example, downloaded images, and how you should arrange them, the orientation that you need to have in order to have a cube that behaves in the way that you want to have it. So yeah, that will be all from my side, except for the part of the time dimension. Here you have mesh cutters. So you could use one of these versions to plot each pixel. So you could put the pixel in time, space, and assign the different value. What is the other one? No, that's not the one. No. Yeah, maybe this one. Yeah. So you could have this kind of cubes as well. So, but the code is already there. So you just need to say, this is longitude, this is latitude, this is time, generate my grid of points, and assign the different colors. And then you could also get these kind of cubes. And with that, I would like to end. Thank you for your attention. Yeah, questions and anything else, you can just submit issues or write an email or whatever. So we are always available.
Any example that you can point in case you want to do machine learning implementation and then predict on the raster?
You can always go and if you want to do machine learning, you can always go to Flux, which is the library that most Julia users have. And there is a Model 2 session where you have examples already where you can just copy paste and use. You have for tutorials, visions. Yeah. Flux, yeah. What else do we have? Yeah.